Welcome to another round of science vocabulary. This week we are going to be learning about the properties of water in a way to kick off our hydrosphere unit. The words this week are polar compound, adhesion, cohesion, capillary action, surface tension, specific heat capacity, and potable. Please make sure that these words are in your science vocabulary spreadsheet right now. You have written down if you've seen them before or not, and you have written down what you think the word may mean based on previous experience or word parts or just guessing. Now, if you have that part done, then let's move on. If you don't, then pause the video, follow those instructions, and then continue. First up, polar compound. Polar compounds are important for us because water is a polar compound. A lot of other things are polar compounds as well. What it means to be a polar compound is that the charges in your molecule are not evenly distributed. For example, water has positive 1 charges with the hydrogen atoms, and it has a negative 2 charge with the oxygen atom. The water atoms are set up in a way that all of the positive charge is on one end of the molecule and the negative charge is on the other end of the molecule. This makes it so that the compound acts a little bit like a magnet, where it has a net positive and a net negative end on the molecule. This is going to make it so that it can stick to and interact with other polar compounds. Things that water dissolves are all polar compounds. Things that water does not dissolve are going to be non-polar compounds. That means that oil is a non-polar compound. Adhesion and cohesion are similar, but they work opposite each other. Cohesion is going to be a property of water that means that it sticks to itself. Adhesion is a property of water that means that it sticks to other things. Cohesion is going to be what makes it so that water affects itself. Adhesion makes it so that water affects other things. Capillary action is going to be what makes it so that you can do little kitchen science experiments like this, where you would stick celery or some other plant into colored water, and then that water is able to travel up the stem of the plant and change the color of the flower petals or the other plant parts. Capillary action is also what makes it so that when you're walking through grass that's wet, then your pant legs get far more wet because that water is able to travel up the fibers in your pant legs. Capillary action involves both cohesion and adhesion, and it is going to be how water sticks to itself and the fibers of a material to move upward against the pull of gravity. Surface tension is going to be based completely on the cohesion of water. The cohesion of water means that the surface of the water is going to stick to itself, and that creates something like a little skin on top of the water that's going to isolate it from the environment. There are organisms that take advantage of this, like this little water strider is able to actually stand on top of the water, even though the insect is more dense than the water. It is distributing its weight evenly across the surface of the water, and so it can stay on top of it using surface tension. This is a really super cool picture of a big cat, and you can see how the surface tension is making it so that the water forms a skin over the top of the cat's head. Specific heat capacity is a combination of two terms, specific heat and heat capacity. You'll see these words used interchangeably, and so we turned them into one term for the purposes of 8th grade science. Specific heat capacity is going to be a material's ability to store heat energy. And so something with a high specific heat capacity would change temperature slowly. It'll warm up slowly and it'll cool down slowly. Something with a low heat capacity is going to heat up very quickly and cool off very quickly. This metal spoon is going to have a low heat capacity because it gets very hot very fast. The pot that this liquid is inside of also has a low heat capacity. That's what makes it so that when you can put it on the stove, then it heats up and heats up the material inside of it. The soup or whatever liquid this is has a lower heat capacity. It's going to take longer to heat up, but it's also going to take longer to cool down. The reason that this occurs is that there is energy that's stored between the molecules in a material. And since water is such a strong polar compound, it is able to store a lot of heat energy between the molecules of water. The water molecule itself is also able to store heat energy by changing the angle between the hydrogens and the oxygen molecule. That's getting into details. Now, the last term that we have is potable. All that potable means is that the water that you have access to is also safe to drink. You do not need a source of water. You need a source of potable water. That means that you can drink it and not get sick. Since water is so good at dissolving things, it is the universal solvent. Since water is such a strong polar compound, it is able to dissolve a lot of things. And since water is necessary for all life, that means that a lot of things can live inside of it. So that means that even when you have moving water outside in nature in what looks like a nice environment, this water is going to contain microorganisms that will make you sick. It'll also contain dissolved chemicals that will make you sick. You need to have treated water. You need to have a clean water source that does not have dissolved toxins or microorganisms living in it in order to drink that safely. Those are our words for the week. I hope that you have a great week in science.